Yep. Okay. So now we're going
Did you say that? Who said that?
The Zoom tells us that to let us know that we're being recorded. Okay.
All right.
And now we're going to try to share this again.
Hi, Mary Lou.
And I am going to share that one. And now do you see the summer, spring, winter, fall?
Somebody, yes or no?
Yes.
Okay.
Yes. Okay. So, you're lost in the North Woods. You wandered away from your camping site, and there you are in the big forest, and you haven't a clue how to get home. Or you don't know what time it is. You don't even know what time of the year it is. You're really lost. So you can, if the sky is clear, you can always use the Big Dipper. Truthfully, any constellation that goes around Polaris, but the Big Dipper is the one we know the best. If it's 10 o'clock at night by your watch, then in the summer, which is where we are now, this is how I'll do it. The Big Dipper will appear in the sky. In other words, it'll be over at, if it were a clock, at 9 o'clock on the clock, and the handle would be pointing straight up in the air. In the fall, it has moved a quarter way around the circle, and it's underneath, so to speak. Then in the winter, it's gone to the right side towards the east, and it's standing on its handle. And finally in spring, and this is how I always remember where the starting point is upside down, straight overhead at quote noontime. And spring has a lot of rain, a lot of water. The dipper is dumping the water out onto the earth. So if you know what, and then of course, if a night is 12 hours long, if it's 10 o'clock at the in the springtime at the top, then 6 hours later, it will look like this. And then at dawn, it'll look like that. So it's moved halfway around the circle during one night. So we can say it's a calendar because it tells you, if you know the time, what time of the year it is. But it's also, okay, go on.
So can I clarify? So at 10 o'clock, it would look like this.
In the wintertime.
And by dawn, it would look like this.
Halfway around.
And then in summertime, it's at 10 o'clock, it looks like this. By dawn, it looks.
Yes.
Okay.
Okay. Right. Very good. Feel free to do that anytime, because lots of times it needs reiterating. All right. We have another picture here, which will allow us to use the Big Dipper as a clock. Now this is a little more complicated. You want to show them where the Big Dipper is here. It's up at 12 o'clock at night, or well, 24 hours. You must use the military times. All righty, so let me think. If I know it's springtime, but I don't know what time it is, and I look up to find the Big Dipper, and there it is, up towards the top of the circle, towards what for us would be midnight, 12 o'clock. Then we know, what do we know? That it's 10 o'clock, because that's where the Big Dipper hangs out in the circle at 10 o'clock in the springtime. And then as it shifts around the circle counterclockwise until dawn, which is down the bottom, we can, if we know that it's springtime, by seeing where the Big Dipper is on the circle, we'll know what the hour is. And what I always, me, your clock can run down, you can lose your watch, your computer can die, your smartphone get lost, whatever. You don't need any of that to tell you the time. Just look up at night, and there, unless it's cloudy, the stars will always tell you what the time is or what the time of the year is. Okay, we can just, why don't we go back to the original circumpolar stars? Okay, Debbie, you there still?
I'm here.
Okay, I think your question was the asterism in the Great Bear.
Yes. The Big
You
Dipper.
like asterisms, so I stuck you with that.
The Big Dipper.
Yes. We tend to think of just the Big Dipper, but really, and now
Right.
it doesn't show you the whole, oh, there it is.
Yeah.
Okay, so the rest of that is all the Great Bear
Yeah, so that's just the Big Dipper.
is part of the pattern that we recognize as an
Yeah.
asterism.
And the whole thing is the,
Okay. All righty, Mary Lou, I think your question was, and it's not on the map, so we often use the Big Dipper and some of its stars as pointers. Now, if we use the two stars, you want to point them out,
Mhm.
at the end of the Dipper, where do they lead us? Keep going.
Lead us to Polaris, which is the
Yes, and so
end of
Polaris
the handle, which
is
is
only a magnitude 2 star, so it's bright, but not that bright. And
Yeah.
so if you want to spot it, you use the end of the Big Dipper to get there. However, the handle, which is
Yes.
curved, also points out a very bright star in the sky. Did you find out?
You can follow the arc of the handle to find Arcturus and then see Spica.
You're right. Well, we don't have, did you all get, were they able to get the sky?
yeah, it's on the website.
Okay, on the web page.
Yep.
Is the evening sky for June. So you can do that, take that white paper with all the black dots and lines on it and just follow it over to Arcturus and you'll see how that works. All righty, I think Laura is running around doing something right now, so she's not sitting at her computer, so I'll answer. Her question was, what's the importance of Mizar and Alcor and where are they? Does anybody happen to know where? I don't have to answer it if somebody else knows the answer. Mizar and Alcor, where are they in the Big Dipper? Okay, it's this here.
That
It's, I believe it's the pair of, it's a double star there in the middle of the handle. And it's famous for two things. Mizar's the brighter of the two stars and Alcor is dimmer. But still, if you have good eyesight and clear skies, even way back in ancient times, it was a test for your eyesight. You could see the two stars without binoculars. But Mizar is also famous in modern times, like the last 200 years or so, because it was the first double star that was studied.
Mm.
So Mizar is a double star as well as Mizar and Alcor. Remember when we talked about double stars? Sometimes there's 2 and 2, or even 2, 2 and 2. I think
Mhm.
Polax is really 6 stars that do a dance around
Mhm.
each other, a common center of gravity. So, and the Arabs, I think, were one of the first ones to talk about those 2 stars and being able to spot them. What's this one? Okay, Jordan, when I woke you up this morning, I asked you, I don't know if you've had time to figure it out because it's more or less you're not going to find it anywhere. You got to think it up yourself. How did Polaris help Columbus discover America? Ta-da.
It's just, I assume it's because it's helpful for them navigating because it always shows them where north is and you can use the latitude and longitude to kind of see how far south you are.
Okay,
I'd assume it's something like that.
yes, partially. It's in the Northern Hemisphere, it's always visible. And because its altitude above the northern horizon, how many degrees above the northern horizon it is, indicates your latitude on the surface of the earth. So you knew how far north or south you were as you sailed across that endless ocean. However, it had nothing to do with longitude, and that was the real problem back in the day. How far west had you gone? Well, they really didn't know until, and I'm sorry, I don't know the details of this. Someone figured out, you need 2 clocks. One clock is set at the time back in Greenwich, England. which a famous observatory was in Greenwich, England. And then you have another clock on the ship that keeps, I'm going to call it common time. And you have to keep them wound. If one runs down, you're in trouble. But then you can compare the time you have at sea and the time it would be back in England. Just like when I called Jordan at noontime here on the roughly West Coast, it was only 9 in the morning over
Mhm.
there. And so they knew the diameter of the earth, and they knew how there were 24 hours a day, so that the sun traveled across the earth at about 1,000 miles in an hour. And so then they could figure out where they were west, or if they were going the other way, east of Greenwich, England. And so then they came up with this scheme. You had the latitude lines that were parallel, going from the equator up to the poles, equally distance apart. And then you had those funny, like an orange segment or a tangerine segment, those longitude lines that started at the poles and swung down through the equator. So at the equator, they were about 1,000 miles apart. How far apart were they at the North Pole?
They just all converge there.
Yep. So the old trick question, there you are standing on the exact point of the North Pole. You take a step away. In which direction are you moving?
I don't know.
Melanie? You're standing on the North Pole. And in any direction you take one step, which way were you moving? North, south, east, west?
It makes my brain hurt.
Ah,
If you, I think if you step to the right, then you're going east.
mathematically, not really. If you're theoretically, yeah, but in the real world, you'd basically be going south no matter what direction you stepped if you were started
Okay.
right
Oh,
at the
right,
North Pole.
right.
Um,
Okay.
yeah,
Gotcha.
you know, that's one of those bar jokes. You get a free drink because nobody can figure it out.
Makes my brain hurt.
All right, let's see. Now, I just want to, okay, I think that was all the questions. Did anybody have a question that I forgot and didn't get a chance to answer?
Yeah, Mary Lou, remember you said if you went out and looked to the north, would Cassiopeia be a M or a W?
Oh, right, that was Rima's
It would be
question.
an M.
Did you look it up? Or
I'm
you went
looking
out?
at the star map right now and I see the Big Dipper where it is in the
Mhm.
spring. Then and I look to Cassiopeia, it's an M. Straight across through Polaris, it's in the shape of an M.
Okay, well, it's across from, where is it here on this one, squint. Where's Cassiopeia? There's Big Dipper. Should be up here. It's not quite directly across. So depending on the time of the year, it might look like an M or it might look like a W. When it's more towards the northern end of the arc, then it looks like an M. Like back this up. But if it's down around here, then it's a W. So, okay. I wanted to mention something about the moon, just to go back to what we were talking about for 3 sessions, because I came across it after the fact and I thought it was really interesting. You got to shift gears for a minute. We're going back to the moon. And remember, as the moon orbited around the Earth, it took I'm going to round it off to 28 days. But it rotated on its axis such that it took 28 days. So the result was the same face of the moon always faced the Earth. We only got to see one side. But I forgot to mention that that meant a night on the moon, if you lived up on the moon, would be 14 days long. And then the daytime would be 14 days long. So once again, we're so used to the Earth being, quote, normal, and therefore assuming without thinking about it that everything else does what Earth does. It's always good for the brain, so we don't get stuck in ruts, to realize that's not true. So if you were a moon person living on the moon, you would have a long night. Like the night before Christmas. Wasn't that? And then a long day. The other interesting thing, and this I thought, wow, I never knew this. The moon was created by that Big Bang. Well, that's the wrong phrase to use because that means something else. A big collision in the early days that created our moon. And because of its size compared to the Earth and the gravitational attraction of each other to each other and the rate of the original spin, eventually it became what we call tidally locked, which meant the rotation and the revolution were the same. So we always saw the same side of the moon. Well, I never knew that in the distant future, and I'm sorry, you'll have to look it up. I don't know when, a million years from now, a billion years from now, don't know when, but the Earth too, in relationship to the moon, will become tidally locked. And then if we were living on the moon, we would only see one side of the Earth, which would mean people on the Earth, all the guys in Russia maybe would see the moon every night. We in America would never see it. You'd have to go on a trip to the other hemisphere to be able to see it. Now, isn't that amazing? I mean, I never thought of that. Can't imagine a life without the moon. Yeah. So I thought that was really, really interesting. And I don't know when it's going to happen.
What would that mean for the tides?
I don't know.
Okay.
She's one of these students that sits in the back row and tries to make trouble. I don't know. Well, okay. The moon is moving further away from the Earth, what, an inch or two a year. Eventually, gravity depends on the size, the mass, and how close it is. So as it moves further away, eventually the effect on the tides will be less, which maybe means in Fundy, instead of 40 feet, they'll only be 20 feet. I mean, they will lessen.
Right.
They will lessen. But once again,
No,
I don't, this is not a qualitative math thing, no, a quantitative math thing. So I have not done the math to know when that's going to happen.
Right.
I wouldn't change my docs in Bundy right now, though.
Right.
I just looked it up. It should be like 50 billion years
50
before they're
billion.
tidally locked. Yeah,
Do we have to worry that what will happen in 50 billion?
that's when they'll tidally lock.
Okay. Do we have to worry about it then?
No,
Why?
according to the internet, the sun will be gone by then, so we'll have other problems.
Right. Well, not only that, the sun will gobble us up before that, probably in another well, anywhere from 3.5, it'll start, and then it'll be done by 5 billion years. Nice to look forward to, isn't it? So when they complain about money spent on NASA, just say, hey, guys, if we don't figure out how to get out of here, there's going to be no humans left eventually in like 3 billion years. Okay. Funny. Let's see, what else do we want to do? Oh, who else has showed up besides?
Mary.
Mary Lou.
What?
Mary Lou?
Yes.
Mary Lou? We had to
Yeah.
change the date for the star party because it's going to be cloudy and rainy.
Oh,
So-
oh,
Can you do it this Wednesday night in a day or Thursday?
I can't do it Thursday.
Okay.
I don't know about Wednesday.
And what about the Pipels? I'll call them. Well, here's how we stand. Sandy, Deb, and I can do it either day, and Rima and Melanie can do it on Thursday. So we're just going to go by the majority. So I'll check with the Pipels,
Okay.
but it looks like it'll be Thursday.
Okay.
Okay.
I have another meeting Thursday, which is more important.
Okay, you be
Yeah.
honest. That's what we need. Okay, let me think. A few more loose ends before I give the questions out for next time. Something interesting is coming up. Write the dates down. Melanie was going to have it up on the screen, right?
I'll get it. Yeah.
Yeah,
I guess
she'll get it up,
I'll get.
but you write it down now and you'll have it on July 11th through the 13th. So that's 3 days. We're going to have another conjunction. Remember that conjunction between Saturn and Jupiter back in the winter? Well, we're having another one. And it's between Venus and Mars. And Venus is our evening star and quite bright. Mars is not so bright at this point in its journey. And the crescent moon. So you could probably look it up online and see a map, a picture of what's going to be happening. But between 9 and 9:30, right after sundown, looking to the west where the sun just went down, you will see bright Venus and smaller, but very close, very, very close, like maybe your pinky between them. And on the first night, the 11th, to their right will be the crescent moon, about 2 days old, I think. And then the next night, the moon will have moved to their left side and they will have gotten closer together. And then on the 13th, probably with your naked eye, they'll look like one. Even with binoculars, they'll be very, very, very close. And the moon will have moved off to the left even further. So hopefully on one of those 3 nights, July 11th through the 13th, we'll have a clear sky and you can see Venus and Mars and the crescent moon. And the reason the window is so small, they are fairly close behind the sun. So if the sun goes down at 9 o'clock or 8:45, they're right there hanging in the west, in the what, the twilight. And so by 10 o'clock, probably they have set. So if you want to see them, I'm guessing between 9 and 9:30. Any questions on that? Okay. Rima looked up the Saros cycle, and I had assumed Saros was some guy that lived hundreds or thousands of years ago, but it turns out that it comes from the Chaldeans. I'm thinking, if I remember right, around 500-600 BC. And it wasn't anybody's name. It simply was the word that they gave to the 18.5-year cycle. And she couldn't find anything else on that. I'm sure there's another reason what that word means in Chaldean, but it's a dead language. I don't know where you'd go to find
How
it.
do you spell that word?
Saros. So you could look that up, Mary Lou. Did it have some other meaning besides an 18.5-year cycle?
So what was this 18.5-year cycle?
Oh,
What
okay.
does it
All right.
show?
Let's go to the sun for a minute as an example. We all know that in summer, which began 2 days ago, right? Yes.
Yeah.
Okay. If you got up at dawn, the sun would be rising off to the northeast somewhere. And if you did that in winter, it'd be rising off to the southeast somewhere. So it moves along the horizon depending on the time of the year. And that's all because of the tilt of our axis. Well, the moon does the same thing. Now, I'd never noticed. I mean, I knew the moon wasn't always in the same spot, but I never thought about it. So the Chaldeans did 2,500 years ago, and they kept track of it. And it takes 18.5 years to go from one end to the other. If you start on the northern end, which is called the northern standstill, because it seems to stop moving for a few days and hover at the same spot. And then back down to the southeast, once again, it hits the southern standstill. And the time between that whole cycle from north to south to north again is 18.5 years. Duh. Okay. Any questions before I give you the next bunch of questions? Okay, now we got things mixed up because of going to Sandy's with the northern view to see the circumpolar stars. We should have done July 6th topic today, but we didn't. And that was about the solstice. Yeah, which we've just passed. So as my old friend John used to say, well, Toots, winter's coming. It's going to get darker and darker every night from now on. I know, but it's true. It's true.
Yeah.
Sunday was the solstice this year on the 20th, and it was the longest day in the year. Okay, questions. Melanie, I won't give Brock one because I'm not sure he'll do it. So Melanie, this is an easy one. This year it was June 20th. What's the range? How many days before that and after that can the summer solstice happen? Okay. This is Melanie. Okay. Debbie, you still there?
I'm here.
Okay. Listen to the question, then I'll go over it. Where on the eastern horizon does the sun rise? Question, what is the shift from December to June in degrees? Because once again, remember, we measure everything not by yards or feet or whatever, but by degrees. So how many degrees does it shift from one extreme to the other? Is that clear? I'm sure it's clear.
Just say it again. What is
Yeah.
the shift in degrees from June to December?
Yeah, June to December, winter and summer. That's the extreme that it will rise along the eastern horizon. And what's the degrees between those 2 points? I think I'm going to keep this one for the Pipels, but if anybody else wants to do it just for fun, that's fine. Going back to the spring equinox, which is in March, where would we find the sun in the sky in the zodiac? In other words, you remember the sun is relatively close to us, and out there on the celestial sphere, remember they thought everything was on one sphere. Now we know that's not true, but it's easier sometimes to think of it that way. And that the zodiac, those 12 constellations that go around the celestial sphere, the sun is always in one or another of those. So right now in 2021, if we could see the stars in the daytime, but we know they're there, where would the sun be? In which constellation? And then Debbie, this is kind of sneaky, you got another one. Where was the sun in the zodiac 6,000 years ago? Because even though we tend to think everything stays the same, it doesn't really over time, over thousands of years. So they're gonna let us know where it is now, and Debbie's gonna tell us where it was 6,000 years ago. And then we're gonna have a chart of the zodiac, and we can see how the sun has shifted in relationship to the background stars in 6,000 years.
Where was
Okay,
the
who
sun in
haven't-
the
who
zodiac
doesn't-
6,000 years ago? Where was the sun in the zodiac 6,000 years ago?
Yep.
So
6,000
why
years.
did you pick 6,000 years, say as?
Because that was roughly the beginning of writing and
Okay.
agriculture. I could have gone back 10,000 years or so, but 6,000 years ago, many cultures, not all, of course, were farmers.
Yeah,
And when we find the answer, we'll realize why a certain constellation was so important in ancient times and revered. And the animal it represented was
Yeah.
often given a good life for a year and then sacrificed. Anyway. All right, who hasn't got a question yet?
Mary Lou.
You.
Mary.
Okay, this is a goodie for you. If the earth, look at my hand, Mary Lou, look at my hand. Oh, if the North and South poles stood straight up and down, no tilt, 0 degree tilt, how would that affect our seasons? Okay, Jordan,
Yeah,
have you had time to do anything about, I don't think I mentioned it to the others, I think it was on the phone to you, that experiment with Uranus and the flashlight and the camera and all of that?
I need some of the materials still, but once I have them, I'll do it. I'll have it ready for the next in
Okay.
2 weeks.
Now, my question is, when whoever takes the pictures, if Megan does that, how, Melanie, tell him how the pictures he takes of his experiment can be emailed to the library.
Oh, yeah. You can just email them to alfred@stls.org.
Say that again.
Okay.
Did you catch that, Jordan? You need it.
Yeah, I did.
Oh, wow.
It stands for Southern Tier Library System.
So I had set up for the four of them a fairly elaborate experiment about that strange planet Uranus, unlike all the other planets. By the way, if anybody wants to, you can look it up. Some planets have, I think, Mercury, not sure, but you can look it up. All 8 planets, poor old Pluto, we don't count Pluto anymore, have a tilt of anywhere from 2 to 3 degrees, which is hardly at all, to ours that we think is normal, 23.5 degrees. And then there's Uranus. Jordan, you want to tell us what tilt it has?
Like sideways.
It's 88 degrees, which means it's practically lying on its side. And as I tried to explain to my elder discussion group, they couldn't get it. That one guy kept saying, why does it roll around on its equator? That doesn't make sense. Why doesn't it just stand up on its whatever? And I tried to explain to him that a sphere, when it rotates around its axis. And if the axis was laying sideways, that's how it rotates. So that meant Uranus went around its orbit on its equator, which totally, as far as we're concerned, mucks up our understanding of what the seasons are like and what the day and night are like. So Jordan's going to do an actual experiment with an orange or a tennis ball and a table and a light and and actually do it. By the way, Uranus takes 84 years to go around. You know, it's way out there. So 84 Earth years to go around once. And he's going to show us the 4 times of the year, what it's like if you lived on Uranus. Okay. I think, what time is it?
It is 1:44.
Okay. Are we going to be able to broadcast our star party to them or not? They have, could we take a hotspot
Oh,
thing with
yeah.
us?
Yeah, I don't see why not.
All righty. We have had to shift our star party because of the weather, and almost certainly it'll be Thursday. So far, Mary Lou was the only one that couldn't make it. So, we'll record it, and then Mary Lou, you can watch the recording. How's that?
That'd be great.
Okay, let's remember to do
Do
that.
I go on the Box of Books website to look for that?
Yes. Yep.
Okay.
Okay. Well, you've attended just about all the meetings, but some people haven't been able to. And then, except for the ones when we forgot to do it, we record these, so you can go to the web page and watch it after the fact.
Okay.
Okay. So Jordan, it'll be Thursday night, 8 o'clock our time. So that's what, 5 o'clock your time?
Yeah.
Okay, so put that down on your calendar. That's in 2 days, 5 o'clock, and you can tune in. We're going out to Sandy's place and sit on her porch or the patio because it has a wonderful view to the north, and we're going to study the circumpolar stars, actually see them, name
Okay.
them, find them. Okay. What else? Anything else? Okay, anybody have any questions about?
Yeah.
Yes.
Could I know what my question was? I might have missed it.
Oh, maybe did I give you one? Wait a minute.
I don't think you gave him one.
Oh, well, I didn't give you one,
Because
Jordan,
you have
because you
an
have this big
experiment.
project to do.
Oh, okay.
Is that okay?
Yeah.
All right. Okay.
Do you have the address for Sandy and Jeff
Okay,
on Vandermark? I'm not sure where they live.
right. Let me just think how the easiest way for you guys to get there.
I know
Alrighty.
Vandermark,
Okay, most people would go to 244
right?
and go over the hill as if you were going to Belmont. And when you get to, you know, where Five Corners is at the
Yeah.
bottom, you go up the hill and down the, turn left, that's Vandermark Road.
Okay.
And my guess is it's about 5 miles on the right. Let me think for a minute.
Can you see her house from the road or? do you have
Yes,
to-
yes. There are at least about a mile or two down the road, a road comes in from the left, and another mile or two down the road, another road comes in from the left. And then I think it's like 2 miles beyond that. So I'm thinking it's about 5 miles from, okay, and then you'll be going through some woods, quite a lot of woods the first couple of miles. And then it'll open up and you'll have pasture on both sides. And the house just before her has this brown painted flat wooden fence. You know the type I mean, it's upright posts and then 2 or 3 horizontal flat boards, and it's painted brown. They're selling off their cattle. They may still have some cattle there. And then Sandy's place is the next one. It's about 100 feet in from the road.
What's the house number?
I don't know,
Okay.
but I'll find out and then call you all. Let me write that down. Now, the other thing, I will get there early. Oh, Sandy has a red Mustang and I have a silver Honda. And so you can see the cars from the driveway on the right side. I should have thought of that ahead of time. I didn't think about it.
Okay, sounds
Okay.
good. I'll
Okay,
find you.
yeah, all right. Well, that's it for today then. Unless anybody has anything else.
Do we
Debbie?
bring our own lawn chair?
Yeah, you should. Oh, that's very good. Yeah, you need to bring, they have 2 or 3 chairs on their porch, but if you have a lightweight lawn chair, that'd be a good idea.
Okay,
I'm thinking they have 3 chairs and the porch step. So 4 people, if you don't have one, will probably be fine.
okay. Great.
And I'll make something, don't know what, but you might want to bring your own drinks, whatever.
Sounds like a plan.
All right, you're gonna bring Steve? I mean,
Yep,
spouses or friends or whatever. By the way, there's a lady named Regina, and I'm gonna let Bob Heipel know because I still don't have her phone number, and she wants to come. So maybe they'll
yeah,
pick her
Regina
up.
Burke,
Huh?
Regina Burke,
I don't know, the lady that's often hanging out
Yep.
here. Yeah,
Yeah,
sure, that'll be great.
all right.
she'll need a ride, Deb.
Yeah, but, well, I think Bob Heipel said he'd pick her up,
Oh, okay.
or somebody will pick her up. We'll find out.
Well, just let me know because I'll be coming by your house.
All right. I'll let you know. Write that down. Ta-da. Let's see, call Sandy's house number and Deb for ride. Then 2 days from now, I'm gonna look at that. Deb for ride. What's that mean? Regina.
I'm gonna look and see if I
So,
have Regina.
Does anybody have any, you know what you might want to think about? This idea of a conjunction where
Oh,
it
Mary
seems
Lou, I
like-
have Regina's phone number
Pardon?
if you want it. I have Regina's phone number if you
Oh,
want
yeah,
it.
okay.
Here, let me stop recording.